but retained its normal mass and gravity, the physics of your daily life would become incredibly surreal. In this scenario, we aren't changing the laws of gravity. We are just changing the shape of the source. Because gravity pulls toward the center of mass, on a disk, that downward pull wouldn't always point toward the ground beneath your feet. 1. The sideways pull. On a spherical Earth, the center of mass is always directly below you. On a flat disk, the center of mass is the exact middle of the circle. At the center, if you stand in the dead center of the disk, gravity feels normal. Down is toward the ground, moving toward the edge. As you walk away from the center, gravity begins to pull at an angle. To you, it would feel like you are walking up an increasingly steep hill, even though the ground is perfectly flat. At the edge, by the time you reach the edge of the disk, gravity is pulling almost entirely horizontally back toward the center. To stay upright, you would have to lean back at a nearly 90-degree angle. If you jumped off the edge, you wouldn't fall into space. You would fall back onto the side of the disk. 2. The Great Sloping Forest. Because gravity pulls toward the center, all liquids and objects would try to migrate there. The global ocean. All the water on the planet would rush toward the center of the disk, forming one massive, bulging mountain of water in the middle. The edges of the disk would be a bone-dry, airless desert. Leaning trees. Trees would grow at an angle, pointing their tops toward the center of the disk to align with the gravitational up. At the edges, a forest would look like it's growing sideways along the ground. 3. Atmospheric collapse gravity doesn't just pull on rocks and water, it pulls on air. The atmosphere would behave just like the ocean. It would cluster in a thick, pressurized dome over the center of the disk. Life at the center would be crushed by immense atmospheric pressure, while life at the edges would be in a total vacuum, effectively standing in outer space. 4. Mathematical comparison. On a sphere, the gravitational force F is consistently F equals gm1m2 over r squared on a disk as you move toward the edge. Distance r dollars from the center. The vector of that force shifts. The horizontal component F sub x becomes dominant, meaning down is no longer a direction but a destination.